Hello and welcome to Empowered Learning. This video will go over how to use graphing transformations to graph exponential functions where graphing transformations are applied. So in our first example, we are asked to graph the function 2 raised to the x plus 2 plus 1. And so if you see, the first thing that we've done here is identify what the base function is. And the base function is y equals 2 raised to the x. And so for any exponential function, we know that it has 3 key points. And so I'm going to reiterate those here. So of course, those 3 key points are -1, 1 over a, 0, 1, and 1a, where a is the base of our exponential function. Here, our base is 2, so everywhere where you see a here and here, we're going to put 2's. Hence why we have these 3 points on the graph of 2 raised to the x. So now that we've established what the base function is, we have to figure out what happened to that particular base function in order to get what the graph of 2 raised to the x plus 2 plus 1 is going to look like. And so the x minus 2 here, what this signifies is that we have a horizontal shift to the left 2 units, which means our graph is going to be shifting horizontally to the left. In terms of x values, that means we are subtracting 2 from all of our x values, and we're keeping our y values the same. So -1 subtract 2 is a -3. 0 subtract 2 is a -2, and 1 subtract 2 is a -1. So all these values stay this change while all of these stay the same. Okay, and so now for the next transformation, we see that that happens by having this plus 1 appended to 2 raised to the x plus 2. And we know that when we see that, that is a vertical shift upward by 1 unit. So since it's a vertical motion, it will affect the y values. So the x values stay the same, while the y values all increase by 1. So 1/2 or 0.5 added to that gives us 1.5. 1 plus 1 gives us 2, and 2 plus 1 gives us 3. And also I want to note is for any exponential function, it also has a exponential function in its base. It also has a horizontal asymptote on the x-axis at y equals 0 here. So anytime we do a vertical shift up or down, that horizontal asymptote also shifts. So that's why you see the horizontal asymptote here being shifted from y equals 0 to now y equals 1. Okay, and so each ticking mark here is half of a unit for this example. So in looking at this, we see that we have our 3 points, which is -3, 1.5, -2, 2, and -1, 3. So here, if we look, this is 1, 2, 3. And we have 3, this is 1.5. So this here is the point -3, 1.5. We see the next point here at 2. That will be the point -2, 2. And then of course this last one here, that would correspond to the point -1, 3. And of course our horizontal asymptote is at y equals 1. So our next example, sort of the same thing, but now we see that we have negative e raised to the x minus 5, where e is an irrational number that's approximately equal to 2.71. It occurs a lot in nature, especially with things that grow at a constant percentage rate, like a population. And it's also, that number is also special because the exponential function e raised to the x is the only type of exponential function that is able to track its own rate of change. Okay, So with that being said, we see that our base function for this one is e to the x again, and our base is e. So our key points to start off is -1, 1 over e, 0, 1, and 1e. And so just so that you know, e is approximately equal to 2.718, blah, 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 and 1 over e is about 3.68. So that kind of gives you an idea of where it will stand. So the main thing that I want to come across here is not necessarily what the numbers are particularly, but to know that we have our function e to the x, and that has been horizontally shifted 5 units to the right. So that means that all the x values, we get 5 added to those, and the y values stay the same. And then here we see that the negative on the outside tells us that we have a reflection about the x-axis, which means all of our y values here, since they're all positive, they will now turn negative. And so that's why our graph is going down like this. And of course, this would be the point 4, -1 over e. This is the point 5, -1, and this is the point 6, -e. And so now we'll go ahead and do some other examples here. So for this one, we know that our base function is just going to be 3 raised to the x, and that's going to give us key points of -1, 1/3, 0, 1, and we have the point 1, 3. Now, aside from that, we can also talk about what happens to this function here. And let's try to give myself some more room. So next we have 3 raised to the x minus 1. Basically what is happening here is that we have a horizontal shift to the left 1 unit, which means we will add 1 to all of our x values. So -1 plus 1 is 0, 0 plus 1 is 1, and 1 plus 1 is 2. And all the x values stay exactly the same. And so now for the last thing, we have the +2 part added on there. So what this means is we are definitely going to add 2 to all of the y values. So we keep the x values the same. So that will be 0, 1, 2. And for the y values, this is now 2 and 1/3. And this is now 3. And for the last one, this is now 5. And of course, we'll make our own order pairs. So we also know that our horizontal asymptote now has moved up to y equals 2. So here we'll just go ahead and make our horizontal asymptote here. And we see that we have the point 0, 2 and 1/3. So we'll just go ahead and plot that approximated about there. We also know that we have the point 1, 3, which would be about here. And we have the point 2, 5, which would be about here. So now we know the general shape of this graph has to kind of ride along here and go up, but never touch the horizontal asymptote y equals 2. So if we come hit this point, hit that, and they just kind of curve along like that, that is what the general graph would look like. Okay? I know it's not pretty, but we kind of get the point there. All right, so for this next one, so the same thing, we have 2 raised to the x, So we know that the key points there are -1, 1/2. We know we have 0, 1, and we have 1, 2. For 2x plus 3, we know that what's happening now is we have a horizontal shift to the left 3 units. So that means we are going to subtract 3 from all of our x values, keep all of our y values the same. So -1 minus 3 is a -4. 0 minus 3 is a -3. And 1 minus 3 is a -2. And so now the last thing is that we need to apply the negative on there, which is a reflection about the x-axis. So here in that regard, we know that all of our y values, which are positive, will now be negative, and if any are negative, they will become positive. So we have -4, -1/2. We have -3, -1. And we have -2, -2. So those are our points now. So the horizontal asymptote for this, since we didn't have a vertical shift up or down, is still on the line y equals 0, which is the x-axis. And so now what we're going to do is plot these points, understanding that the profile of our graph, since we know it's a exponential function that goes up like this, but is being reflected about the x-axis, so now it has to go down like that, and it's going to be below the horizontal asymptote. We know essentially the graph's going to go something like this. Okay. So using every half unit, every ticky mark here is a half unit. I'm going to consider this to be -1, so that's -2, -3, -4. So let me count that again. 1, 2, 1, 2, 3, 4. Okay. So at -4, -1/2, that would be our first point. And then at -3, -1, that would be our next point. And then at -2, 2, that will be that point. And so now again, we know that we have a horizontal asymptote, so all we need to know is that graph will kind of look like this, and it will go down but never actually reach y equals 0. And so this concludes the video on how to do graphing transformations to exponential functions.